The universe is everything that we can observe. From the smallest particles to massive stars, and even vast galaxies and galaxy clusters. They are all part of the universe. This also includes the dark matter and dark energy that we cannot see. The scale of the universe is unimaginable, and it is filled with mysteries. Throughout history, humanity has explored the origins of the universe, and various theories have been proposed to try and explain it. However, the most widely accepted explanation is the Big Bang Theory. According to the Big Bang Theory, our universe originated from a hot, infinitely dense point. About 13.8 billion years ago, this point began to expand. And then matter, energy, space, and time were created. In the early universe, there were two main evolutionary stages, the radiation era and the matter era. After the Big Bang, the universe first entered the radiation era. This stage was dominated by radiation and lasted for tens of thousands of years. The radiation era was composed of several smaller stages. The first stage was the Planck era. The Planck era lasted from 0 to 10 or 43 seconds. During this extremely brief period, only energy existed in the universe, and the four fundamental forces of nature were unified. At the end of the Planck era, gravity separated from the four fundamental forces. Afterward, the universe entered the inflationary stage. During this period, the universe rapidly expanded. Inflation lasted only 10 or 33 seconds. But the scale of expansion was incredible, reaching 10-30 times. During this stage, the strong nuclear force separated, and energy began to transform into matter, leading to the quark-dominated period. Next, the universe entered the electro-weak stage, where electromagnetic and weak forces began to separate. Protons and neutrons formed, and as the universe expanded and cooled, about 0.01 seconds after the Big Bang, photons, electrons, and neutrinos formed. The universe then entered the nucleosynthesis stage, where protons and neutrons fused to form the nuclei of light elements. This stage marked the end of the radiation era. After the radiation era ended, the universe began to enter the matter era. The matter era was characterized by matter dominating the universe. It is divided into three stages. The first stage is the atomic stage. About 300,000 years after the Big Bang, the universe cooled to 3,000 degrees, a temperature low enough for electrons to attach to atomic nuclei. This process is known as recombination, leading to the formation of a large number of hydrogen and helium atoms. At this time, the universe became transparent, and photons could finally travel through space. The second stage is the stellar stage. As a large number of hydrogen and helium atoms formed, gravity began to take effect, gradually pulling them together to form gas clouds. Once these gas clouds appeared, gravity caused them to contract and collapse, forming a high-density core. As more matter accumulated, the temperature and pressure within this core continued to rise. Eventually, when the core reached millions of degrees, hydrogen ignited, and nuclear fusion occurred. At this point, the first generation of stars began to form. The final stage is the galactic stage. After a large number of stars formed in the universe, these stars triggered a massive chain reaction. They began to group together, slowly forming smaller clusters. These clusters then merged with other clusters, gradually merging and engulfing each other, eventually forming large galaxies. As time passed, the continuous death and rebirth of stars, the collisions and mergers of galaxies, ultimately created everything we see today. This is the evolutionary process of the universe. Although this is only a theoretical hypothesis, it is the most widely accepted explanation by the scientific community for the origin of the universe.